Hey YouTube, so I found this quirk in AWS that lets you host content without paying data transfer rates. I created this proof of concept that hosts a demo video, and we don't pay a cent for running it. So let's check it out. If we open it up in IE Edge, it'll start playing the Big Buck Bunny video. We can actually have a look and see where this data is coming from. If we start monitoring, we'll see when the next chunk loads that it's coming from S3, but it's not a bucket that we own, it's a AWS bucket. So stick around and I'll explain how this works, and you can even try the demo out for yourself at the XSS Fox Big Buck AWS GitHub page. I'll put the link in the description. So the reason I started looking at this was I noticed in AWS there's a Lambda limit of 75 gig of storage. I thought that was really odd because a lot of other AWS services, you can essentially have as much storage as you like because they'll just scale up. And the reason why they let you have as much storage is that it's usually build. You usually build for the data transfer in and out and the storage of the blob itself. So that's why I sort of got looking into, hey, what's going on here, and is there something that I can exploit? So to understand how this hack works, it's easiest if we step back and look at how a typical stream works. A typical stream uses a protocol called HLS, and the way it kind of works is that you have a playlist file, that's the M3U8 file. And inside that file has all the instructions for the player to grab the content and play it. So typically your content is broken up into smaller chunks. This lets you stream them easier, so you could just download a chunk at a time. So say we have a M3U8 file. It might have several .ts files, and they're the MPEG stream inside the file. They actually contain the video. The client will essentially ask for the M3U8 file and then basically run that playlist. So you can think of it very much like typical playlists. Play the first thing, play the second, third, fourth, etc. And that file has a little bit of extra like metadata information to say how long each chunk is. So the client will go off, grab those files, pull them, play them. And that's sort of why you end up with that sort of jumpy step in the loading bar, because you'll load a little chunk at a time. So now that we know how a normal stream works, let's also have a look at how Lambda itself works. And at the core of it, basically, if you're using it normally, you're putting some code, like some Python files, you might have some auxiliary data that you need to process. You're putting that in a zip file, and you're uploading that to AWS to process. And the way you're uploading that is typically to the AWS API. So behind the scenes, what the AWS API is doing is it's uploading it to its own S3 bucket, and that's what it uses to store your Lambda function. Now, I don't know the specifics behind the scenes stuff that AWS is doing, but I suspect when you have a cold start Lambda, it's fetching it from that S3 bucket, which is why it takes a little while to start the Lambda function up. So one of the other things you can do in Lambda is also get the function code back out. So if you have a look at the web console for Lambda, you'll notice that you get that nice editor that lists all the files in your Lambda function. And if it's small enough, you can actually edit your code inside that editor. And so the way that's working is it's running this get function call. And that gets all the information about your function, so like the environmental variables, the runtime. It also gets a link to the code itself. Now, the get function API doesn't actually give you the code. It's not part of like the JSON response that comes back. What it's giving you is a pre-signed URL to the code, and that's a pre-signed URL to the item in the S3 bucket. Now, that pre-signed URL is valid for 10 minutes, so while you have that URL, you can download it as many times as you want from anywhere. The URL works from anywhere. And it's a normal like S3 pre-signed URL. So you just can curl it and download the data from it. So this is useful for our attack because what that means is we can upload anything to Lambda and download it again. Now, the only sort of problem with this is it has to be a zip file. You can't just upload bare files to Lambda. So we can't just grab our MPEG, rename it as .zip, and upload it. It actually checks to see if it's zipped. So to get around that, we have a little bit of a solution to that problem. What we do is we actually grab our TS file. So that's our movie content. And we zip it up, but what we do is we zip it with 0 compression. And that means the file itself is still there in its original form, just that when we've zipped it, it's added a zip header. So there's actually like 2 sort of zip headers that we need to care about. There's the zip header itself is sort of at the end of the file, and this tells the zip utility like where all the files are. There's also a header at the start of the file, so this isn't for like the zip file itself, but each individual file inside the zip file. So that leaves us with like a slight problem in that we can't really get the video stream to like download a zip file and uncompress it. So we use this sort of little trick by having it zipped with no compression. The original file is still in there, and then we just use this XX bytes range feature of HLS. And that gives us the advantage of saying, hey, when you're downloading this file to play it in the client, only download the bytes between 67 and 23,401. That means we can skip the zip header. We can skip this entire start of the file and end of the file and go straight into the content. So that leaves us with one problem that we still need to solve. That pre-signed URL is only valid for 10 minutes. So if we had a 10-minute movie, we could do the get function, get the URL, and host it back to the client. The problem with that is we also need to refresh that URL. So it's not like we can just stick a pre-computed M3U8 file in an S3 bucket and go from there. To get around sort of the time limits of the URL, what we do is we actually create a new Lambda function. And to be honest, this part of the process doesn't necessarily have to be Lambda. It could be on just a Raspberry Pi or something else like that. I've just picked Lambda because it's easy for me to work with. So we just have this Lambda API that when the user hits it, it does that get function and returns back a 302. So it will redirect the HLS client to the pre-signed URL. That means we don't need to hard code in specific URLs for each chunk of data that we need. We can just put a generic URL and have that code run, do the get function, and redirect the client. So what does this look once it's sort of all together and in one piece? So we have the user. It will request the M3U8 file, and that can be sitting in a bucket or stored on GitHub. It doesn't really matter. And inside that file, it will have all the TS files listed. With those TS files, it has the bytes range set, so it only gets the bytes that are required for the TS files, so no zip headers that it has to worry about. And it will also have the URL to the Lambda function that's sitting behind an API gateway. So it'll go to that Lambda function. It will provide, the Lambda function will do the get function, get the pre-signed URL. That pre-signed URL will get sent as a 302 to the client. The client will redirect to the S3 bucket to grab the data. And remember that S3 bucket is an Amazon S3 bucket. It's not our S3 bucket. Grab the data from that bucket and play the stream. So hopefully that explained how that entire system works and how we can upload a Lambda function that contains a movie, not have it execute, but be able to pull the code back down onto the client. I just wanted to quickly sort of finish this with how much does this cost? And essentially you have no data transfer costs. So there's nothing in terms of like S3 costs, because that all happens in the Lambda's internal AWS bucket. Like it's not in your account, that's someone else's bucket. What you do get charged for is running that Lambda function that runs the get function out of AWS to get the link to the source code. That costs, but Lambda is so cheap that it's teeny compared to anything else you try to do. To prove that, the demo's been running for a couple of days now, and I've got the Cost Explorer up in AWS, and I can see that there's no data transfer costs in here at all. There's API Gateway, Lambda, S3, but there's no cost for any data transfer. So it definitely works. And the very final thing is, should you use this in production? Probably not. At some stage, Amazon is going to probably find a way either to bill you for this data transfer or lock it down so it's not feasible to use it in this particular scenario. So hopefully you had fun and learned something new. And if you have any questions, leave them down in the comments.